This brief learning session revolves around spirocyclic and bicyclic and bridged cycloalkane nomenclature. So to follow along, please access Chapter 4 materials from Blackboard, and the file name is cycloalkane IUPAC. Chapter 4.zip, file name 4.5 cycloalkane IUPAC. So you can pause until you acquire that. The page, what we'll be doing is just the last page. Okay. This material was discussed in class. This material was discussed in class. This material has not been discussed yet. Okay, so this has been reserved for this online session. Just one page of material. Okay, so the formula that we'll want to apply is this one. Make sure how these are named. Officially, Spiro, bracket, and the bracket is necessary, not a parentheses, a bracket, need the bracket, X and Y, X dot Y, this is not a comma, this is a period. Okay, so to follow the formula, do it like everyone else does it. Spiro, bracket, X dot Y, bracket, alkane. Whereas X and Y are numbers as derived pretty fairly based on the above half-worked example. And also the alkane is the total number of carbons in the structure. So if it's 12 carbons, it's dodecane. If it's 11 carbons, it's undecane. If it's 9 carbons, it's nonane. So this one happens to be 10 carbons. Overall 10, if you add up all the carbons in the ring from tip to tail, it's 10 carbons overall. So the ring is 6 for the cyclohexane ring, 6 carbons, 7 carbons, 8 carbons, 9 carbons, 10 carbons overall, decane, that's why it's decane. And the numbers take a little more introspection where numbers are based on the number or quantity of carbon vertexes proceeding from the carbon atom, and there's only one of them, from the carbon, which is in common to both rings. Okay, so pencil down here, pencil down at this carbon. How do we figure out what X is, what Y is? So find the common carbon atom for both rings, find that common carbon atom, pencil down, and then almost as if you're walking on a trail in a national park, walk 3, 2, 1, go. Walk. Carbon 1, carbon 2 on this trail, carbon 3, carbon 4, back at the origin, back at the parking lot. I could have went this trail too. Counting down, 3, 2, 1, go. Carbon atom number 1 on the trail, carbon number 2, carbon number 3, a vertex is a carbon atom number 4, number 5, and back at the parking lot. So that's where the 5 and 4 came from. Its full name is Spiro 5,4-decane. You could buy it on Aldrich if you wanted to. You can purchase it. So let's try this one here. So this is the carbon atom in common to both rings. Okay, so we're going to go start here and end here. This is a spirocyclic. What makes a spirocyclic a spirocyclic? You have one common carbon vertex for 2 rings, spiro. So let's go. Ready, set, go. Don't count this one in terms of your XY because this is your origin and your ending. So you can't count it according to the rules. We will end up back at the red dot. And we're back. So one of these is going to be 6. And by convention, we label the one with a larger number first. So it's labeled in descending order. Let's try the other circuit, the other trail. Okay, so this is the starting point, the parking lot. When you hike, you start at the parking lot and you end at the parking lot, don't you? So let's go. You may be asking, could I have gone clockwise? Yeah, it doesn't matter if you go clockwise or counterclockwise, so it doesn't matter. What matters is that you collect all the carbon atoms and you don't count the origin as part of this carbon collective. So 6, 5, Spiro 6, 5. Bracket, bracket, period. And now I just have to count up all the carbon atoms overall in the parentheses. How many vertexes are there? 7, 9, 10, 11. Oh, really? Wow. 8, 9, 10, 11, 12. Wow. There's 12 carbons overall. Dodecane. Okay, so that's how we do that. A live example for you. Okay, this is in contrast to fused ring systems, where for spirocyclics, it's a nice way to start this out. You start and end at the same carbon. That is not the same case for fused ring systems. Fused ring systems, as you can see here, rings share 2 consecutive back-to-back carbon atoms. So these carbon atoms are both shared, whereas for Spiro, only 1 carbon, 1, how many? 1 is shared for both rings. Here for fused ring systems, you have 2 vertexes in common to both rings, not just 1, 2. So if we start here, initial I, and we end here, final F, then our path can take us along the cyclopentyl or the cyclohexyl. And the third path, for reasons to be explained in bridge systems, could be from fused ring to fused ring, but in so doing, there are no carbons along that path, are there? So that's why the 0 comes in there. Okay, so it's named, the generic formula we want to subscribe to is bicyclo XYZ alkane. In other words, bicyclo XYZ alkane. In other words, X, Y, and Z are numbers, and we'll do an example in a moment. And alkane, again, is the total number of carbons. So overall, how many carbons are in this structure? 8. So this is an octane. Now we just have to figure out, because we need the bicyclo prefix to designate it's that type of molecule. So we'll preface it with bicyclo. Now we just have to figure out, to name this molecule here, what are X and Y, because X, Y, and Z. Okay, aren't these the 2 carbon atoms which are common to both rings, the 7-membered and the 3-membered rings? They both share or have part of their carbon collective, those carbon atoms. So, okay, so we can start here, initial, and end here, final. And by the way, you could have I and F inverted. That is to say, this could be I and that could be F, so that doesn't matter. Okay, let's go. And again, we want to name these in descending order. So, okay, so don't count the initial point. Don't count that. Okay, carbon 1, vertex 2, counting the vertexes up until we reach the fused carbon. So this is 5. I'll have to do it down here. So I offer my apologies for you for that. 5. Let's try the other one. Initial, final. How many carbons do you hit before you reach back to final, just one. 5.1.0 octane, bicyclo 510 octane. So I don't believe you can really like check and make sure this is internally consistent with respect to octane and 5.1.0. So it's not like you can check your work if you multiply, you can check your work by dividing it. So there's really no check that comes from that. So that's okay. And fused ring systems and bridged ring systems. Bridged ring systems, the rings share two non-consecutive carbon atoms. So if you were to take a look at this part of the molecule, that's a 5-membered ring. And so these carbons here are not back to back because there's a carbon, this is called the spire carbon, almost like a church has a spire. A spire has height, like where the church bell would go into the spire has height, the spire carbon. So these pegged carbon atoms here are not back-to-back consecutive because the spire carbon is in between them. So that is what this is called, a bridged ring system, as opposed to a fused ring system, because over here, these carbon atoms were consecutive, adjacent to each other, and these are not. If you were to even number the ring system like this, I could do this for you. 1 IUPAC wise, just with the cyclopentane ring, 3, 4, and 5. So it is carbon 1 and carbon 3, which had the pegs. Whereas over here, if you do it over here, 1, carbon 2, here, carbon 1 and 2 have the pegs on them. And they're consecutive back to back, whereas carbon 1 and carbon 3 with the pegs on them, with the spire in the middle, are not back to back. This is a bridged ring system. Contrast that to a Spiro system, which is only one carbon atom in common. As you can see, there's only one, it's a Spiro. So we want to apply rules similar to fused ring systems for bridged ring systems. Okay, so we'll have a carbon atom in common, a carbon atom in common. Try to write out the name here. And the overall number of carbon atoms in the structure that we will solve is 7. It looks to me like a chair with a spire on it. Spire has height, right? A chair is a shape of a cyclohexane ring, which you may know at this point in time. Okay, so let's try this, these pathways here. If we have this, if we mark this initial and we mark this final, can you tally up how many carbons are in between the initial and final markers? So if we go this way, 1, and we're at the end of the short hike. If we go this way, over the spire, over the hill, 1, and back down there. So it looks like it's 1.1, and we're looking for the last number. These again should be named in descending order. Okay, so we're going this way, 1, another vertex, and we're back to the final. So 3.1.1 is the number formulaic. So bicyclo 3.1.1 heptane. So those are examples worked for those and those molecules in addition to the ones already on the page, and then we'll leave these for you for open-ended. See what will happen with those on the page. You can try those out if you like.